JVN Kumar Chandra, Assistant Professor in Department of Science and Technology, Faculty of Education and Methodology, in Jyoti University, Jaipur. In the previous session, we have discussed about the introduction part of grid computing. Now, in this session, we will discuss an overview of applications, and then after that, we will see the applications. So, in the applications, it is National Virtual Observatory. The terabytes of data is placed, is there of various kinds of information, and how the data is managed, or how it is the computing part takes place. So all the things comes under the grid computing. It's because we are using this technology for that. So first one is the high energy physics. So when we talk about this, a large scale calculations for CRN's large Hadron Collider. So in the high energy physics, there are a number of institutions, and number of countries are there. So the data sets now are at petabyte level. Just because if there are 4,000 physicists are involved, 150 institutions involved, more than 30 countries are there. So what we supposed to see here is that there will be petabytes of data. So what data will take place at that time? So the predicate to generate data at the exabyte level in the D. That means this unit is way more than the petabyte. So there will be very large data set at the end of decade. So there are some challenges also. So it's providing rapid access to subset of data to secure access to distributed computing in data handling resources. Now we come to the next slide. So here essentially providing distributed collaborative infrastructure that will allow physicists from around the globe to effectively analyze the results from their home institution. Like if someone want to do some computing, or when we are talking about the physicist, so he just needs the information at one's desktop. So what he need to do if he want to do some large computing or large calculations, so how it's supposed to be done there. So it is simple. So I am using my laptop here, so I will avail some services for the grid, and then I will upload the task. Now, when we see the online access to scientific instruments, and it's a photo, it's a photon, advanced photons of here, the real-time collections, tomographic reconstruction, archived storage. It's running on the software or desktop with VR client share controls here, and a wide area emission that's here. So these are the access points here. It's like at the endpoint, a user is just doing this thing. It's controlling from the software, and the desktop or VA clients, the share controls, they can control, or they can view, or they can manage the network here, not the network precisely, but the task assigned to them, or the resources that can be met. Now we talk about the NEAS. So NEAS, it's NSF Network for Earthquake Engineering Simulation. So it's transport, or just like if we have any earthquake at any place, so how we can define that? So we have some data that can be analyzed for some time, and then we just take some output out of it, and then we see that there might be a possibility. So it's just a prediction. So in prediction, just we use the machine learning algorithms. How this can be managed. So when we talk about the when we talk about this, so if the data is managed, so the data, a very large data set is there. So it's about the land, its weather, and the things placed there. If there is a factory or there is a mine, so then these will also be considered. So there are many things. Now, when we talk about the different geographical areas, so here there is something else, here something else. So these are the possibilities. So when we build a nuclear power plant, so this can be at the place where some living is there, some people around there, or just regular earthquakes or some storm condition. So this must be at some calm place. So very simple as that. So what is the NIST? So NIST is the network of 15 large-scale experimental sites. Advanced tools such as check tables, centrifuges that simulate earthquake effects. It's like we just check that bridge construction. So we just prepare a model of a bridge or a flyover. Then we just put the weight on it. How much weight it can bear, or simply we see some kind of vehicle experiments. So we just make a small vehicle, or we just add something into it, and then we just see how aerodynamics works, and how the weight placement is there. So there are some models. So it's linked to a centralized data pool and earthquake simulation software. So a data pool is there. We are just connected to data, and earthquake simulation software that analyze the data and then produce some results. It brings together by the high-speed internet. So why the high-speed internet? Just because it's within milliseconds, anything can be changed. So if we get the information right before 5 minutes of earthquake, so there are many things to be manageable. 5 minutes are 5 minutes. That means we have 300 seconds right now. Otherwise, it just happens. Now, next, securely store, organize, and share data within centralization server in central location. So it just store the data in well organized manner, and it also share the data with the vendor. It's remotely observe and participate in experiments to use the synchronized real time value. Now we see a synchronization between the server and our system. Just like we see the email. So in email, what happens that the email has arrived at my email ID, which is on server, but it's not showing on my phone or my laptop. So if I'm refreshing it again and again, so it will synchronize with the server, and the mail will appear in my laptop or phone. So this is the thing. We need some real-time synchronization, or when we talk about the video, we often talk about the live streaming always. It's like there are many softwares out there that's in live. So can you share the video or some kind of audio or some any information? So this must be live. Live means that means it's just real time synchronization. That's right. Next, so, collaborate with colleagues to facilitate the planning, performance, analysis, and publication of research experiments. Like this thing also supports some kind of planning, and some performance must be there. Like if it's synchronizing with the server, then its performance must be very good, and the internet connection will well function. Analysis, how the data is analyzed, publication of research experiments, like the previously not done by anyone. Conduct hybrid simulations that combine the result of multiple distributed experiments and link physical experiments with computer simulation. So the computer simulations are the best right now. So we just input the data and then we just run the simulation so that the data can be analyzed with the available data. If I want to predict the rain, then what I must save, I must save uh, rainfall data of previous 50 or 100 years. After that, I can analyze that at these circumstances, at this place, the rain was good or rain was not good. So then I can also give the prediction that this crop will be fine here and this crop will be diminished. So these are the suggestions about that. So we can calculate or we can analyze the previous data and we can some predict some new outcomes. Just like a rainfall data is fair and days, and the climate conditions are also similar every year. So it is obvious that the time will be the same. In the sense, the almost time when the rainfall will be there and rainfall will be there is the same. But when every year some environment is changing, nature is changing, then we can predict precisely. So there will be a nature change. Next, we talk about DOE Earth system wind. What is the Earth system wind? So when we talk about the Earth, we see some horizontal and vertical lines. So these lines are commonly is called grid, as they are making the grid from horizontal and vertical lines. So its goal to address the technical obstacles to the sharing analysis of high volume data from advanced Earth system models. Now, when we talk about this in context of grid, then we are talking about data modeling. So when a high volume of data is there, we just put the data into some blocks. It's like how many blocks are there, which block number is containing which data, and how much data that block is analyzing or something else. So here it's not about just storing the data. Here we are analyzing the data. So how the data is analyzed. So the first thing is to store the data, then analyze the data. So we are storing the data, then we will analyze that. So in the analysis, if there is specific data from some place, then we can predict things just like this you can see here. If wind is coming, if wind is coming from this side, then it is obvious that here is India, India. Then it is obvious that if wind is coming from this side, then the rain can come from this side. And then what are the geographical conditions of India? Just like if India is like this. Then if wind coming from here, then there is some there is Himalaya, there are mountains also. So these will stop the wind, and then this place will always be as before. So this also affects. So we must analyze the data as much as possible that we can give the precise results for that. Now, just see how the places are. Now, when we talk about this, so high resolution and long duration simulation performed with advanced DOA climate models produce tons of petabytes of output. That means a long duration simulation is performed on that, and this is high resolution. That means in the details it sees. So these advancements lead to the tens of petabytes. Like it's not just regular storage, but it's a lot of and contains a very large data set here. So this output made available to global change impact researchers nationwide is available for everyone, both at national laboratories and universities, other research laboratories and institutions. So this data is shared with universities, colleges, laboratories, national laboratories, researchers, everyone. A virtual collaborative environment that links distributed centers, research, models, and data provides scientists with virtual proximity to the distributed data and resources that they require to perform the research. So it's just providing us that data to perform. It's just providing the data to perform the operations or for some experiment purpose. Now, now we will talk about the virtual organization. So let's play the virtual organization. So the members of this class represent the virtual organization within the university, and the resources of virtual organization include a laptop, workstations, printers, belonging to individual or virtual organization. Now there is a question. Does this bring up an issue you are consulting yourself about? Are you having any questions here? Just like how my system will be secure? How it will be? Is there any data loss in that? Or how much my system will up or it will be working? How much time it will take? And what are the resources? If my laptop or my PC's performance will be down due to this grid computing thing. So we will see these things in the next sessions. So if we want to tightly control who may use the resources in how they may use, so the security is a big concern here. It's like if I'm giving the access of my computer, then how much access I'm giving to that particular person. It matters a lot. So we need security and some specific rules that defines define how we manage the security in the system. Now let's see an example. So, want to tightly control. Okay. So how about the Larry and Raman wanting to see your printer at the same time? Is this a problem? Might be a problem, but there is some small time period that might be there. So the result is might want to have a scheduler, which is in case not need to more sophisticated the turning of the printer. So I don't want to turn off my computer. So there is a scheduler. So if the first come first service, if one gives the gives about the if Larry gives the print first, then the Larry will give the printer. If the instruction is it takes time to reach the instruction to the printer. So if Larry's instruction is the first one or Sarah's instruction is the first one, respectively, it will print. Now, here's the second thing. What if David forgot Dan's IP address and cannot again access his laptop? What could this be resolved? Now, this is the thing. I don't know, but I want to resolve this problem. So, when David forgot Dan's IP address, so it's not getting the access. So what can we do? So here we can provide an information service that could tell David how to find the laptop. Okay, and here also deal with around getting multiple resources. It's like uh, how to take the printout or something else with the resource manager. Now we also need to monitor the application and executing in virtual organization way. So these are the things about virtual organization and some examples. We will see Git computing software infrastructure in the next session.